Welcome to He's Dead Jim, finding JavaScript memory leaks with Chrome DevTools. So a little about me. My name is Tanner Maris, like Lindsay just said. I'm a developer here at Planning Center. And this was actually part two of another DevTools talk that I gave a couple months ago here on JavaScript profiling and finding expensive JavaScript functions and using Chrome DevTools to find that. So if you want to hear that, that's kind of the precursor to this. It's on our Full Stack Talks YouTube channel, and you can find that there. But today, I want to talk about memory issues. And so my grandma has this really hard time, no, I'm just kidding, not those kind, memory issues in our applications because they're very visible to our users. And the three ways that memory issues proudly display themselves to them. First one, performance just being consistently bad. And this is possibly a symptom of memory bloat. And memory bloat is when a page is using more memory than is necessary for it to optimally run. Another way that users can see this is that the page is delayed or appears to pause frequently. And that's possibly a symptom of frequent garbage collections. So garbage collection is when the browser reclaims memory. And the browser just decides when this happens. So during any collections, all script execution is paused. So if the browser starts garbage collecting a lot, script execution is going to get paused a lot as well. And the third one, and the one that actually we're going to talk about today, is performance getting progressively worse over time. And this is going to be a symptom of a memory leak. A memory leak is when there's a bug in the page that causes the page to progressively get use more and more memory over time. And the browser is just going to slow down to a crawl, possibly even, if you've all seen that screen before, He's Dead Jim. This is Chrome's default display when a page has stopped responding. And I just kind of love the ending of like the solution to this is to continue, reload, or just go somewhere else. Like there's nothing we can do about it. So the two ways that we're going to try to find these memory leaks are using the DevTools Heap Allocations and Heap Snapshots. What is a heap? So I looked it up, and we're going to turn into a CS class for a second. So a heap is a specialized tree-based data structure that satisfies the heap property. Pretty simple, right? That makes total sense. If you're still confused, there's this great site, www.google.com. For further reading on that, you can find some more stuff. But basically, it's just a JavaScript, or it's a data structure that holds all the JavaScript data in memory. So we'll keep it at super high level and simple. So the first one we're going to talk about is heap allocations here. To show you that, we actually have to do some code stuff. So let's get out of here. And here's my application. It's called Super Cool Events. I'm going to actually close this tab so I don't get any desktop notifications. So Super Cool Events is an app I made. It's just really popular. I mean, it's making me thousands of dollars per month. I don't even know why I work here still. But I got a user complaining about the page getting a little bit slower as they're using it. So they told me specifically it's when they're adding events. So I kind of know where to look. And so to kind of investigate what's going on, let's pull up our DevTools. So to do that, I'm going to make these a little bit bigger. That's good there. That's probably good enough there. So if you don't know how to bring that up, it's Command-Option-I on a Mac. I don't think Windows even has DevTools. So you probably have to switch to a Mac. But you could go up to View Developer, and it's probably somewhere in here, right there. So there's three. I'm on the Profiles tab automatically because that's where I was when I last closed it. But we've got all these tabs here. We're going to focus on the Profiles tab. There are three different profile types. We've got the CPU profile, which is the one that I talked about in the last talk on DevTools. The two we're going to use today is this heap snapshot and the record heap allocations. So the first thing we're going to do is look at the heap allocations. And you can see it gives a little definition of what each section is. This one records JavaScript allocations over time, and we use this profile to isolate memory leaks. Great, total self-documenting there. So we're just going to hit start and start messing with the app and see what happens. So you can see this little timeline starts triggering, and I'm just going to click my add event, and I'm going to hit escape to close it. So I've got that functionality built in. And I'm just going to do this a whole stinking bunch and just kind of watch the timeline. And it looks like something bad is already happening, so I'm just going to keep on doing this for a second. Man, this is great. So I'm actually simulating, I've got users using this thing, and they obviously create thousands of events a day for this thing to get slow. There we go, that looks good. So I hit the record button. I don't know if you saw me do that. I started recording the Heap profile. I interacted with the site, and then I stopped it. And then the DevTools kind of compiles all that data, gives us a count of all the objects allocated, gives us tons of info. But really, we can actually see pretty quickly, just with this visual graph here, something bad is happening. We've got this kind of gradual slope going from 0 up to the 100K mark here. Each one of these blue lines is actually a heap allocation. So this is actually new objects being put into memory from JavaScript. This is not a good thing. If you see an app that does this, this probably means it's got a memory leak. So every one of these little dashes here was me probably hitting the close button, and it was allocating some new object. We don't know what it is yet, but it was allocating a new one each time I did that, and you can just see it slowly, gradually growing. Healthy applications don't do this, right? We don't expect just while the app's sitting there for it to just slowly grow and grow and grow, because eventually the computer's going to run out of memory, and then it's going to crash our whole computer. Or if the browser, stops it before that, we'll get to the browser. Oh, the browser will crash first, like that. He's dead, Jim. We can get a little bit more detailed here. So this is that entire sequence of events that I just did. We can drag this timeline here and zoom in on just specific events if we want. But pretty much the heap allocation part, we're done using. All we wanted to use it for was just to sniff out if we in fact did have a memory leak, and I think we do. So we're going to move on from heap allocations. Let's go back here. So we've got a leak. Where is it? I thought this picture was really fitting. It's actually one of the default ones from this template, and I was like, wow, it's a giant dam. Like, how would you find a leak in a dam? That'd be crazy. So we've got a leak. Where is? Oh, sorry, I was actually explaining more here. The next thing we're going to use is heap snapshots. So as the name implies, a heap snapshot is a way to show you how memory is distributed among your page's JavaScript objects and the DOM nodes. And it's a specific point in time, right? So it takes a picture, it freezes time for a second, and gives us a list of all the JavaScript objects we have and all the DOM nodes that we have. And again, easiest way to show you is just to actually show you. So let's go back into the app, and I'm going to clear this profile here. Let me scoot this down just so I got a little bit of, there we go. I'm going to refresh the page just so I kind of clear the memory out, and we're going to change the profile type to take heap snapshot. And so first, page just loaded, and we're going to take a snapshot. That just gives us our baseline, right? We need a control group to compare something to. And now I'm going to go ahead and do that exact same thing where I'm just, progressing through the app. We have tons of, like a good user, I never refresh the page. I just hang out on the same one for days and just hope that it keeps working without refreshing ever. Maybe 30 times. Is anybody counting? About 20, 31. Okay, that's probably good. So let's take another one. So instantly, I noticed something. And if you look in the sidebar here, it's pretty obvious. So when we started the page, I was at 4.8 megabytes. Just by opening and closing my form, somehow I've added almost double. Now I'm at 7.2 megabytes. This is also not a good sign, right? So we definitely found where this thing's at. But how can we use these snapshots further to help us figure out what's going on? And if we look at this list, so this constructor section here gives us the list of every single object we have, and it's pretty giant. Just keeps on going. And it tells us some things about it. We get objects count. Great, 16,000 things are in here. That's awesome. Oh, gives us sizes and stuff. We're not really going to look at that right now. But if you look, we're in the summary section up here, and the one thing I want to do is probably limit this list a little bit to give us a little bit more focused view. So I'm going to change from summary to comparison, and DevTools is automatically going to choose something to compare it to, and right now it's chosen snapshot 1. I believe as long as you only have 2 snapshots, it'll always just pick the other one. But if you have 5 or 6, just make sure when you are doing this comparison, you pick the right snapshot to compare to, so you're not comparing the wrong one. So here we're on snapshot 1, that's good. And if we look, this list got a lot smaller. And I don't know if you noticed this, but we got some new columns too. We have this new and deleted and delta section. And one thing I want to point out is if we go down towards the bottom here, here's this weird thing here. So we've got 234 new things. None of them got deleted. So let's take a look at these detached DOM tree elements. And if we dig into here, holy smokes, what are those? And so we go in, we got text thing here, HTML input element, okay. So DevTools highlights this thing in red. And if I can find another one here, I think HTML div element is the right one I want, yeah. And then we have this other thing highlighted in yellow. So DevTools is giving us a little hint about something. Anything highlighted in yellow are nodes that have direct references to them from JavaScript code. And so they're directly tied to JavaScript. Nodes that are highlighted in red actually don't have direct references. They're only alive because they're part of some other yellow node's tree. So they don't actually have a direct reference to JavaScript. And that's kind of hard to visualize, so I actually have, I have a little graphic for us to help kind of explain this. So here we've got a very distinct, very clear distinction between objects in JavaScript land and something in HTML land. We've got window with its key down event, and the DOM has some sort of inputs, right? And normally if we remove inputs from the DOM, they're detached from the DOM, the garbage collector is going to come over, look, see that they're detached, and remove them nicely for us. And this is perfect. This is exactly what we want. But something interesting happens if we bring them back and we attach them, give them a reference to something in JavaScript. So now these inputs are attached to the window. Now when we remove them from the DOM, the garbage collector is going to come by and see that there's still a reference, though, to them to window. And they're just going to kind of hang out right there and not get removed. We've just created a detached DOM element. And so again, a DOM node can only be garbage collected when there are no references to it from either the page's DOM tree or JavaScript code. And then that node is said to be detached when it's removed from the DOM tree, but some JavaScript code still references it. So I hope that makes it a little bit clearer. Now that we know what the problem is, we found those 240 detached DOM nodes that are just hanging out in memory, being ignored by the garbage collector. We should try to fix them. That is our problem. So let's go back and see if we can clean that up. So coming back to Chrome here, now we need to do some code stuff. Make this a little bit smaller. I'm just going to clear these for right now. So here's our app. It's just one JS file and one index file. And are those visible for everyone? Right about there, maybe. So we know the problem was those HTML input elements. We know that it happens when they get referenced by the DOM or referenced by JavaScript. So I'm just going to say that Windows probably my problem, and I'm just going to search for a window in my JavaScript. Luckily, there's only 3 places that I can't make that any bigger. Sorry. Window.app, window.location.reload, or window.addEventListener. Aha, that one is probably where our problem lies. So there, display create. There she is. This is going to be too hard to see. So this is our problem method. What are we doing here? Let's just walk through it really quick. So we've got variable inputs. This is a new jQuery element. It looks like we're making a input field named node or named name, and then we're making a button that says create event. Cool. We're replacing some create node with those inputs, and then we're focusing on that name. So that's when I do this. That's the name input right there, and there's that create event button. Okay, we're tracking along here. After we focus on name, we're then adding an event listener key down. We're checking that if it's the escape key. We do some other check to make sure the inputs aren't hidden. And then we swap out that HTML again with a new jQuery element that has the add event button back in it. And then we run some app setup, whatever that is. So it looks like every time I hit escape, I'm just swapping out the HTML that was in there, putting back that add event button, and then they reverse when I click that. We just wipe out the add event and throw those two things back in. This is not very performant, right? We're creating new elements every time I'm hitting escape and swapping them out. What might be better here is instead, what if we just had the same two elements and we just kind of toggled them on and off, right? That makes a little more sense. So if we have some create form and we just hide it, and then we have the add button and we show that instead. So let's switch it to do that. That seems reasonable. I'm just going to copy all this HTML out of here, and let's go back to our index. Here's our create form that has the add event button, so I'm just going to add that to the top. So we've got our text field with the name, we've got our create event button, and then here's add event. I'm just going to move that down right below. So now we've got this create form all packaged together as one, and then we've got the add event button with the new class right underneath it. This is already looking better. I'm already happy about this. So now we need to do something different though. We don't want to destroy or swap HTML out. We want to grab the create node like this. And then instead of swapping the HTML, all we want to do is just show that thing, right? So that seems pretty easy. And then we want to do the same thing, or do the opposite, with new. So we're going to go ahead, make a new thing, just call that new. And instead of showing it, we're going to hide that thing. So now we're, now we're hiding that new add button, and then we're showing that whole create form. We can actually do something really cool, is get rid of all the stuff that was in the event listener about swapping and destroying things, and just do the opposite of what we're doing up here. So now we're going to hide create. I don't need that. And we're going to show. So let's make sure the code still works. Uh-oh. Our create form and the add are there at the same time. So remember, what I was doing before was I was using JavaScript, creating that element and shoving it into the HTML. So I didn't really care that they both existed at the same time, because I was always just shoving something new into the create node. Now that both exist at the same time, we need to make sure that one is hidden by default. So in my little app setup, I'm just going to make sure that create is hidden. And since I'm not a designer, I'm not going to do this with CSS, even though I could easily do it. But so now I just hide it when the app loads. Setup gets run right when the page loads. So let's make sure that's working good. Yay. And so now when I hit add event, I hit escape, hit add, hit escape. Yay. So as far as the user is concerned, the functionality is identical, but we fixed something that was causing some problems. Something I want to point out here is this actually could be slightly better. So if you notice, inside the add event listener event handler, we're actually using a reference that we created outside of that. And as of right now, you can tell that it works just great. It's fine. But just in case we don't want to get another stale reference like we had before, let's just go ahead and grab a new reference inside the event handler. Even though it costs a little bit more as far as the jQuery performance, doing a simple query like this shouldn't be too bad. So it's safer as far as the memory leak's concerned to get a new reference inside the event listener, and then we can save some variable creation if we wanted to, and just do this. We thought we were being good JavaScript developers, good jQuery developers, and saving those, but actually in this case, it's going to be better to do something like this. So if I refresh, it still works. Great. So functionally, this is working. Let's see if we actually fixed the thing we were trying to fix. So first, we're going to use that heap, the heap allocation, which is our memory leak sniffer, and see if that graph changes at all. So we're going to hit. Let me refresh again, just in case. So I'm going to hit start, and I'm just going to start doing that thing over and over again, like I was before. And at first, you can see the garbage collector was kind of being a little greedy, and it kind of allocated a little bit more, or it was being lazy, actually. But now, as we keep going and keep going, if you remember what the graph looked like before, there was a blue line pretty much every click. Now we're getting a heap allocation maybe every 10. Now it looks like every 20. So that's looking way, way better. And you can see by the snapshot, I sat there for a little while, still at 5.2 megabytes. So heap allocation-wise, we're looking a lot better. There's only one of these little big guys, which I don't know what in the world he's doing there, but just got excited. And then all the rest are totally minimal, totally good. We like what we're seeing here. So let's double check. We're gonna be good. And before we push this out as fixed, we're gonna go ahead and check that our detached DOM tree elements are fixed as well. So I'm gonna refresh the page, take a snapshot. Looks good. Gonna do some hopefully not bad stuff anymore. Simulating my users who just are super busy. They create hundreds of events. I was trying to think of what to say while I was doing this, while I was rehearsing, and I still ran out. I'm out. So you guys just get to watch me play with this. All right, that's good. I'm going to take another snapshot now. Hey, that already looks way better. It's slightly more, right? 0.1, but I'm pretty sure we've solved this. So again, in my second snapshot with the second one highlighted, change from summary to comparison. Snapshot 1 is over here, is what we're comparing to. And if we look for those detached DOM nodes, I don't see any. Right? We've done it. We fixed our little memory leak. So no more detached DOM nodes. JavaScript's happy. Memory's going to be happy. We could sit there all day and open and close that form, and it's just going to use the same two events or same two nodes. So in recap, heap allocations, find out when new memory is being allocated in JavaScript, and we can visualize that memory usage over time. Heap snapshots help us identify detached DOM trees, which are a common cause of memory leaks. For resources, Code School has a great DevTools course. I believe the entire thing is a free course now, so you can do every section of it. It's a little dated. It uses like one previous version of DevTools, but it's still, the lessons are still pretty applicable. You just might find a button in a different spot or something. And then developers.google.com has all the documentation for DevTools. That one is up to date, and another good resource. That is it. That's my website and Twitter. If you want to tweet at me at any time. Any questions? Cool.
All right. Thank you, Tanner.